This video is sponsored by Harting Technology Group. Harting Technology Group is 100% family-owned German company with experience of more than 75 years. Initially, it was concentrated on the production of everyday consumer goods. However, during these 75 years, Harting evolved into a global leader in supplying connectivity solutions for the three main branches of industrial technology: data, signals, and power. Its portfolio also includes amazing custom-made solutions and products for railway systems. We invite you to check out the link in the description if you're curious to find out more about this interesting company. Thank you, Harting, for supporting Railways Explained, and now let's get to the topic. Welcome back to Railways Explained. Today we are talking about one Norwegian mega railway project which is currently in the implementation phase, the Follo Line project. The Follo Line is in the moment the largest transport project in Norway and one of the most important high-speed railway projects in the world. The main reason supporting this claim is the great technical complexity linked to this project, and you will soon find out why. The Follo Line project includes the construction of 22 km long double-track high-speed rail line between Oslo Central Station and the new station in the town of Ski, for a speed of 250 km per hour. The line will have the possibility to accommodate both the passenger and freight transport. It is a continuation of the Norwegian National Rail Administration's intercity plan to build 4-track lines along the three main corridors out of Oslo. The first was the Gardermoen line, completed in 1998, and the second was Asker line that was completed in 2011. Currently, between Oslo and Ski, there is a line known as the Eastfold line, which was upgraded to double track and higher speeds between 1989 and 1996. As the Eastfold line has reached its capacity and the population growth of at least 30% is anticipated in the region by 2025, the construction of a new connection with a new hub in the city of Ski is imposed as a logical solution. Now we come to the point. Constructing new rail tracks in such a dense metropolitan area as it is the case here is a huge logistics challenge. Furthermore, one of the constraints of the project was to cause the least amount of disruption possible and to end much of the work without interfering with the daily traffic flows. You also might be wondering what kind of mega project it is that includes the construction of only 22 kilometers of rail tracks. Well, these 22 kilometers cost as much as $2.35 billion. The reason? Well, they include the construction of 20 kilometers of tunnels. But not ordinary tunnels. These tunnels will pass under the existing busy road tunnels. We got you, right? Okay, we'll come back to that later. The Follo Line project is divided in three sub-projects: Oslo Central Station, tunnels construction, and the surface section and the new Ski station. The contract strategy for the Follo Line project has been formulated based on its size. The project has 5 EPC contracts for general contractors and 1 single contract as frame agreement. It is split into the following main contracts: Civil Oslo S, approach and connection to Oslo Central Station; EPC Railway Systems Oslo S, connection of railway systems to Oslo Central Station; EPC Tunnel TBM, the Tunnel TBM section; EPC C, surface section and the new Ski station; and frame agreement for signaling system. Now, let's dwell in more detail on the construction of tunnels. The tunnel concept consists of the construction of a twin-tube tunnel named the Blix Tunnel, which will be the longest railway tunnel in the country. As we said, the total length of the tunnels is 20 kilometers, but it is divided according to construction methods. 18.5 kilometers of the tunnel has been excavated in rock using tunnel boring machines, and by drill and blast and drill and split methods in the remaining parts towards Oslo Central Station. The project is characterized by the fact that the double tunnel was created simultaneously with 4 TBMs, each one 150 meters long and weighing 2,400 tons. Also, an innovative solution was used for the access of TBMs. The project comprised the construction of a single-access site in the rural area of Ausland, about midway between Oslo and Ski. From there, 4 TBMs were launched, 2 in each direction. which excavated at the same time and at a close distance for long stretches. The underground assembly tunnels, 20 meters high, 50 meters wide, and over 60 meters long, are the biggest ever made in Norway. It is definitely a record-breaking building site. In Ausland, a low-impact base camp was built, with over 500 homes for the workers, but also offices, a gym and a canteen. A factory to manufacture the segments needed for the tunnels was also built, so they can be transported while avoiding heavy traffic. The tunnel was lined with over 20,000 rings, comprising 135,000 segments. The starting shot for the first machine was given in early September 2016, in the presence of the Norwegian Prime Minister Erna Solberg and the Minister of Transport Ketil Solvik-Olsen. On 11 September 2018, two of the four moles, Queen Euphemia and Queen Elisive, made the tunnel breakthrough simultaneously, ahead of the schedule, while the other two TBMs, Magda and Anna, made a spectacular double breakthrough as well, in sea on 26 February 2019. The tunnel boring machines drilled a hole of 9.96 meters in diameter, excavating about 9 million tons of rock, lining the tunnel with concrete segments, producing a smooth and watertight solution. Overall, the excavation of the 4 TBMs lasted about 2 years, involving over 750 workers and 100 engineers and technical staff from 25 different countries. The remaining 1.5 kilometers of tunnels represents the connection with Oslo Central Station. For this part, it was necessary to use the second method because the railway tunnels pass beneath the existing Ekeberg Road tunnels, one of Norway's busiest road tunnels. In addition, space is limited by various forms of infrastructure, including multiple oil caverns. Another important factor for the future urban environment is that the Alna River, which is the longest river in Oslo, will be able to pass above the railway tracks. The horizontal pillar between Ekeberg tunnels and follow line tunnels is less than 4 meter thickness. The thin pillar and the requirement to keep the traffic safety in the Ekeberg tunnels on high level at all time made the construction of the follow line very challenging and demanding. We could break down the conditions for the construction of the follow line into 3 main requests. First, there should be no negative effect on the stability of the Ekeberg Road tunnels. Second, the traffic flow in the Ekeberg tunnels had to be maintained at all times. And 3, any risk of instability in the existing tunnels must be detected beforehand so that all necessary precautionary actions could be taken on time. The exit from Oslo includes an additional tunnel that connects the station with the existing Eastfold line. While drill and blast is used outside the critical area, the excavation method specified for the area under the Ekeberg tunnels was the drill and split. Briefly, this method involves drilling holes in the rock mass, then using mechanical force to split the rock, and finally using a mechanical hammer to loosen the remaining rock from the rock face. The method is highly applicable in places with strict vibration limits and in situations where blasting is forbidden due to short distance to other infrastructure or other construction works. The main construction phase commenced in 2015 and is scheduled for completion by the end of 2022. Once out of tunnel, the trains on the follow line will travel over a stretch of approximately 1.5 kilometers before arriving at the public transport hub in sea. Trains will pass underneath the new Norby Bridge, which was reconstructed to make space for new tracks. The new sea station is being built with 6 tracks and 3 central platforms, plus a new underpass, a road bridge, a bus terminal, and an extended car park, all with the aim to enable accessibility, efficiency, and integration in the urban environments around Oslo. The vitality of a particular urban area, along with its plans for growth, development, and economic attraction, can be measured in part by its mobility systems. When designed to be sustainable, mobility becomes evidence of a city's capacity for innovation, as well as a formidable tool for enhancing economic strength. The Follow Line project is a clear example. The new line was designed to decongest the traffic in the southeastern outskirts of Oslo, but also to integrate the public mobility of the small towns around the capital. When it finally starts operating, commuters will be able to halve their average traveling time from about 22 to about 11 minutes. The number of trains crossing Oslo daily along the route will increase from current 12 to about 40. Local and freight trains will continue to run along the Eastfold line, while regional and fast trains will move along the Follow line. Along the same corridor, the new line will facilitate 11,000 more trips per day, with an average increase in frequency of 43% and up to 67% at peak periods. Notably, the new line will amount to a daily reduction of 5,800 car trips, contributing to a reduction of 5.4 million tons of CO2. As the Eastfold Line connects Norway to continental Europe, with 80% of all land-based international freight transport going through it, the Follow Line will contribute to a significant capacity increase on international freight traffic. The rail administration has set a goal of tripling the amount of rail freight by 2040, which for the South Corridor is equal to the removal of 750 trucks per day from European route E18. The Follow Line will also allow freight trains to pass during the rush hour, which is not the case today. In any case, this was the story about the Follow Line project on Railways Explained. Railways Explained team will be trying to keep you posted about this and all other interesting railway projects that we are covering on our channel, especially on our Patreon page. So consider supporting us there with a small monthly donation so we can continue improving our production. We hope you enjoyed and learned something new about the railways of the world. Don't forget to like this video, share it with your rail-loving friends, and of course subscribe to our channel. Until the next time, goodbye.